This experiment is about magnets, or rather a falling magnet. I've got a small but strong neodymium magnet here, and I'm going to drop it down each of these equal length tubes, one after the other. And I'd like you to notice the sort of length of time it takes to go from one end of the tube to the other. I've marked them with blue tape. Ready? 3, 2, 1. Well, no time at all to get to this first tube, but then you wouldn't expect it, would you? It hasn't got very far to fall. Let's try tube number 2. And you can see if I hold it up beside the other, it is the equal length. So, ready? 3, 2, 1, go! Well, very much longer. Now, I wonder why this is. Now, you're probably saying, well, one's metal and one is plastic. Well, you'd be dead right there. This one is actually plastic, and this one is metal. But it's not a ferrous metal because the magnet doesn't attract it. It's actually copper. Anyway, so when the magnet moves down the tube, something happens. And as you probably know, if you have a magnet and you move it in and out of a coil, you get an induced voltage. This induced voltage produces a current, and this current produces a magnetic field. Well, that's exactly what's happening here, because as the magnet falls down the tube, it produces a voltage and therefore a current which flows round the tube, and that gives a magnetic field. But by Lenz's law, the magnetic field produced in the tube opposes the magnetic field of the falling magnet, and so slows the magnet down. Remember Lenz's law. Now, I've drawn you a picture of that, and it has a little bit of writing with it, and you can find this explanation in my website, www.schoolphysics.co.uk, a detailed version of this experiment.